Okay. Given below is the graph of y equal f of x, use the graph to do the graph of y equal f of x plus 3. And we'll do the same thing we did before. We'll graph the answer in green. And I'm going to do the rough mock-up again and then just shift things around. And so I have the point -2, 1, the point -1, 1. Then we have 1, -1, and 2, -1. So I'm just going to move the graph over here. So -2, 1 right there, -1, 1, the origin, 1, -1, 2, 1. So there's what the original graph looks like. Just moving it on there so we can see it a little bit better. Then y equal f of x plus 3. It's going to be the basic shape, but the plus 3 inside is going to be a horizontal shift. And then it goes backwards to what we expect, left 3 units. So I'm just going to take each one of those points and move them left 3 units. So I'm going to take this point here, move it left 3 units. 1, 2, 3. It ends up there. Take this point, move it left 3 units. 1, 2, 3. It ends up there. Take my origin point, move it left 3 units. 1, 2, 3. It's there. Take that point right there, left 3 units. 1, 2, 3. Right there. And then take that last point, move it left 3 units. 1, 2, 3. There, each one of those points where I just moved it left 3 units. Then connect my dots. And there's my graph. Okay, let's do some of our other basic shapes then. So my thought process here, my basic shape comes from the cube root. Which is that shape. The plus 5 inside. That's a horizontal. I have trouble spelling horizontal. That's horizontal. Left 5. You go opposite to what you'd expect. And so again, I'm not expecting amazing works of art. Left 5. 1, 2, 3, 4, 5. Then I'm just going to take that origin point, move it left 5, and then draw the same basic shape. Good enough. I am not looking for any more detail than that. And like I said, as far as the computer, some of these are multiple choice, some of them are not. Some of them do try to have you do the graphing. If you come to the ones that you actually have to do the graphing and you can't figure out how to do it on the computer, reach out for help. Okay, next one. We got 2 things going on here, but it's going to be the same thought process. We just decide what each thing is doing for us. So my basic shape comes from the square, which makes it that parabola. The -7 on the end. Or better yet, not inside. Sometimes they will try to trick you by putting that number up front. What's really important here, it's not on the inside. That's going to be vertical, and in this case, down 7. The -4 inside well, that's going to be horizontal, opposite to what you'd expect, so right 4. So, rough graph, and that's all I'm looking for come test time. Not going to look for amazing works of art here. down 7. I'm going to take that origin point, go down 7. So 1, 2, 3, 4, 5, 6, 7. So there's negative 7. Right 4. 1, 2, 3, 4. There's that new origin point. And then draw my parabola. That's all we're looking at. Now here, if I could bring up my computer and share my screen with you, which I can't with my current technology limitations, I would show you how to graph on with my labs. But I can't, so let's just white that out. Okay, next thing we're going to talk about, reflection about the x-axis. And we are not talking about everything you can possibly do. If you're a textbook reader, there's some things that we aren't doing. And so when you read a textbook, if you read a textbook, most of you don't, but if you do, or you watch some videos, that you find some YouTube videos, and you watch, because I've posted some YouTube videos for you. If they talk about things, textbook or YouTube videos, talk about things that we didn't talk about, ignore them. We're only going to do reflections across the x-axis. You can also reflect across the y-axis. We're not going to be doing that. So shown below are the graphs of f of x equal x squared, our standard parabola, and f of x equal negative x squared in green. And so we can see that all the negative does is it flipped it. So a negative out in front of the function flips it across the x-axis. We call that reflection across the x-axis. And so that's what we have summarized here. The graph of y equal negative x is the graph of y equal f of x reflected about the x-axis. Just means flipped over the x-axis. So I got that same basic shape there again. So we're going to try to do the same thing. Now this one's a little harder to do, but we'll try to figure it out. So we're going to do all my points again here. So that point there was negative 2, 1. That point's negative 1, 1. That point there is 1, negative 1, and 2, 1. Okay, so negative 2, 1 right there, negative 1, 1 right there, 0, 0. 1, negative 1. So there's the original basic graph. And so this guy, answer in green. So y equal negative f of x. The effect of that negative, we flip it across the x-axis. So, trying to do that. So if I have this point here, and it's 1 unit above the x-axis, when I flip it across the x-axis, it's going to go to 1 unit below. If it's 1 unit above, and I flip it across the x-axis, it's going to go to 1 unit below. Same thing here. 1 unit above, flip it across the x-axis, it's going to go 1 unit below. The origin is going to stay the same. When I flip that, it's not going anywhere. Then this point here, since it's 1 point below the x-axis, 1 unit below the x-axis, when I flip it, it's going to go to 1 unit above. And same thing here, 1 unit below is going to go to 1 unit above. So it's just their location with respect to the x-axis that changes. Their location on the y-axis doesn't change at all, but the x-axis changes. And then connect our dots, and there's my graph. Okay, let's look at this next guy. So my thought process here. The basic shape is the absolute value. And that's the V shape. It's minus 5 on the inside. That's horizontal. Goes opposite to what you'd expect. So right 5, the minus in front. flips it across the x-axis. And the plus 2 on the end. More importantly, not inside. That's vertical. And that's going to go up 2. So, almost out of room, that's okay. We don't need amazing works of art. So we're going to go right 5, up 2. So 1, 2, 3, 4, 5, up 2. There's where that new origin point is going to be. Right 5, up 2, and then instead of opening up, it opens down. And that's all I'm looking for. Just do what each thing says. Right 5, up 2, flip it. Okay, the last thing we can do to these graphs, or that we can do, that we are going to do. Vertically stretching and shrinking graphs. So I'm going to pick on that x squared again. And the f of x squared we've got in blue in the middle. And then 2x squared we'll do in yellow. And it's there. And what we've said has happened here is the graph has stretched, that it's going up faster. That's what's called a vertical stretch, that it's rising faster, stretching up high. And then in green, 2/5 x squared, it's this guy here. Now this textbook calls it a vertical shrink. Stretch and shrink seems to go better. I've seen many textbooks call it a compression. So if you, from high school, if it was called compression, or you read YouTube videos, compression, I actually do like the stretch and shrink. It's shrunk because it's not going as high as fast. It's shorter, so to speak. So a number, positive number out in front is this vertical stretch or shrink. If the number is bigger than 1, it's a stretch. It rises faster because you end up multiplying each y coordinate by that number. They're multiplying all the y coordinates by 2. If the number is less than 1 but still positive, it's a vertical shrink because you're like cutting, in this case, you're cutting each y coordinate down by 2/5. So the number out in front, we're talking about positive numbers. Number out in front, vertical stretch or shrink. Bigger than 1, stretch, because you're multiplying the y coordinates by a number bigger than 1, so they're getting bigger. Less than 1, so between 0 and 1, a shrink, because you're cutting them down by half, 2/3, or whatever the number happens to be. There it is detailed. Let f of x be a function and c be a positive real number. And again, we're talking about positive numbers. If it's greater than 1, it's a vertical stretch, multiplying all the y coordinates by that number. If it's less than 1, again, talking about positive numbers, if it's less than 1, it's a vertical shrink, multiplying all the y coordinates by that number. Now, if it's negative, it'll do the flipping, and then still do the stretching or shrinking by whatever the number is. Let's end that video and go on to the next problems in the next video.